could this same technology work in mostly like methane atmosphere or any sort of other atmosphere, like on Mars or Titan, that could still work in that atmosphere? I know that would be very far in the future, but
I don't see any reason why it couldn't, as long as you have the thermodynamic cycle. That's what you're looking for. If you've got some kind of compression process, heat addition process, and an expansion process where you can get thrust out of it, yeah, I don't see any reason why you couldn't. I think it's very doable. It's a thermodynamic cycle. That's essentially what we're looking at, and however you get that, it doesn't matter. You get creative.
Well, what would you say would be the most important thing that you want people to know right now? What is it that is the focus of your attention that you want to make people aware of?
I think the major thing that we want people to be aware of is that these systems can be flight tested at a very low cost, because that's been the sticking point and is currently the sticking point for these high-speed air breathers. We just don't have enough flight test data or flight testing that we're doing now. And doing flight testing, I mean, it's critical. We can't, if we don't do the flight testing, we can't verify the tools that we have. So we can keep developing like we have been, but we don't really know how far we're getting because we don't have any experimental data, some flight test data to back it up and verify that everything's working. So what we're trying to do when we started out this project was basically to develop a low-cost method of flight testing high-speed air breathers. And so it kind of spawned into an access to space type propulsion system when we found these smaller satellites, nanosat industry starting to blossom. We were looking for applications because it's been hard to get interest in the lower cost high speed air breathers. But if we can find a lot more applications, then maybe there'll be other groups that say, hey, let's flight test these things and really start getting into them. Because that's where we're going to find out all those unknowns that right now we're not going to know until we actually get our fingers in there. And the flight testing that has been done on them has been done so long ago, the people that were intimately involved with those flight tests now are retired. And so you lose that experience base. And I think it's really hurt that industry quite a bit. So I think for the most part, we see a real opportunity for air breathers to help out in space access. Not that you can't do things that are maybe totally different, because you're still looking at basically boosting some kind of payload up. But what we're really focused in on is there a small a launch vehicle that we can make that's much smaller than what a rocket is in order to open up new markets. That's what we're shooting for with the high-speed air breathers. If we can make a launch vehicle that's smaller than an all-rocket propelled vehicle, a combination air breather rocket, how small can we go? Because the all-rocket from the ground is going to be fairly sizable just to put itself up there. And they're working with air launch systems now, but even if you're dropping the rocket off at 45,000 feet or so and Mach 2, you still have a lot of delta V in order to get access to space. And so it's still going to be a fairly sizable rocket to do that. So we're looking to open up the market for space access in the smaller payload range. And so I think that we are focusing in a different area than most of the other groups that are out there. Because if we can keep the nanosatellites, give give them a primary payload seat in a vehicle, I think that would really help to open up that small market.